Okay, students, after the first completion of the lecture 1, next we are going to start with the lecture 2 of chemical kinetics. Okay, so in this session we are going to complete the dependence of the rate of reaction on concentration. We are going to complete what topic? Dependence of rate of reaction on concentration. Okay, how concentration is going to affect the rate of reaction. Okay, so already in general I told you what I told you in previous lecture. We have just introduced what factor on what factor rate of reaction depends. There are certain factor in general relation I gave you. Okay, in general rate of reaction is directly proportional to concentration of reactants. Okay, so but it is only in general. Okay, but actual relation, quantitative relationship is given by two different theories. How many theories? Two different theories gives you the quantitative relationship. Okay, so what are the quantity that they are? The first one is law of mass action. What is the first one? Law of mass action. Okay, second one is rate law. So these are the two different laws. There is some difference in between them. Okay, but they are going to give you about what? Dependence of rate of reaction on concentration, how concentration is going to affect. They are, the thing they are informing you is same, but the way of informing, the way of calculation, the way of relationship may be different. Okay, so that's why these two laws we are going to discuss. Okay, so first what we are going to study now? We are going to study the law of mass action. One by one we will compare both of them. We will complete both of them. After that we are going to complain. Okay, so compare, not complain. We are going to compare. Okay, first let us start with the law of mass action. Okay, this somewhat introduced in the first year or 11th class only, and in the chemical equilibrium you must have studied. Okay, if you don't remember, don't worry. We are going to discuss from the basics to advanced level on each and every topic. Okay, that is the advantage of this class. Okay, so law of mass action says that rate of reaction is directly proportional to directly proportional to concentration of each reactant with each concentration term raised to exponent equal to coefficient or numerical coefficient in balanced chemical equation. In balanced chemical equation. Okay, so don't worry, it appeared to be very lengthy but very easy. So rate of reaction is directly proportional to concentration of each reactant, with each concentration term raised to the exponent equal to numerical coefficient in balanced chemical equation. So that is the definition part. Okay, and if you understand the explanation, this definition is going to be very easy to remember. Only thing, understanding is important. So I am going to explain you in the other way. Okay, so let us take A moles of A react with B moles of B. So this is some product. Now I am not writing product. Why? Because rate of reaction is now more depending on the product. So once we are not able to relate it, then why to write? Understood? So law of mass action, according to the law of mass action, rate of reaction directly proportional to concentration of each reactant. Okay, with each concentration term raised to the numerical coefficient exponent equal to numerical coefficient in balanced equation. Okay, that means R directly proportional to A to the power of A, R directly proportional to B to the power of B. So we can directly write R directly proportional to A to the power of A and B to the power of B. So once we want to remove some proportionality, generally what we will do, we will write it with equal and K. So A to the power of A and B to the power of B. So this is the mathematical expression. This is the mathematical expression of the law of mass action. Okay. So is it understood? So before using that, the main thing we require is balanced chemical equation. Sometimes what they will do, they will give you the unbalanced equation, or deliberately they will give you the wrong balanced equation. Nowadays it is very difficult to survive. Okay, so what they will do, they appear, it appeared to be some coefficient will be written, but it will not be balanced. Okay, so for that you should not believe anybody, especially examiners. What you will do, you will cross check the balance. Okay, whether the reaction is balanced or not, because entire formula is purely depends upon the coefficient only. Okay, now this is the law of mass action definition part and the mathematical relation. We are going to discuss some more terms related to it. Okay, so let us take R is equal to, now I am writing what extract of this previous. R is equal to K into A to the power of A and B to the power of B. Okay, here R is already known, rate of reaction. Okay, what is rate of reaction? It was clearly explained in the previous session. So K is called as rate constant. What it is called as? Rate constant. So but sometimes this everybody knows. Okay, that examiner also knows. That's why what they will do, they will use the other word. What is that word? Specific rate of reaction. So this appeared to be rate of reaction, but it is not rate of reaction. Okay, specific rate of reaction. Specific rate of reaction is not rate of reaction. It is rate constant. Okay, so what is this rate constant or specific rate of reaction? See, when this becomes 1, then this also becomes 1, then this becomes this. Okay, so when this and this becomes 1, then this becomes this. So that is called as a specific rate of reaction. Okay, so you don't understand, don't worry, I will explain now. So specific rate constant or specific rate of reaction is equal to rate of reaction when concentration of all reactant are taken as unity. That means this is one molarity, this is one molarity. So 1 to the power of something, 1 to the power of something will be 1 only, 1 into something, this only. So this is equal to R. So rate constant is nothing but rate of reaction, but only thing specified what is the specified? Concentration must be equal to 1. Okay, so that is the definition of rate constant. Okay, is defined as this. Its definition I will write it here. Okay, definition, is it understood? Definition, it is rate of reaction. Rate constant is equal to what? Rate of reaction. Okay, when concentration, but condition is there. What is that condition? Concentration of all reactants. Concentration of all reactants taken as unity. That means 1. Taken as unity means 1. Okay, so that is the definition. Is it understood? So law of mass action and that only rate constant. Up to here, is it understood? Now we are going to discuss the other term. This discussed already in previous lecture. This discussed now. Now we are going to discuss some other terms. Okay, that other term only very important. What is the other term? Molecularity. Okay, molecularity. Molecularity is equal to sum of coefficients or sum of exponents. We will write better exponents. Okay, of concentration terms in law of mass action equation. Law of mass action equation. Okay, this is the law of mass action equation. This is the concentration term. This is the concentration term. Their power to be added. Then you will get molecularity. Okay, so I will write individually also. I will write overall also. So molecularity of reaction. Okay, I will write Rxn. You should understand. Rxn reaction. Okay, so with respect to A, with respect to A is equal to small a. Okay, same way molecularity of reaction with respect to B is equal to what? Small b. Then comes overall molecularity. Overall reaction molecularity is equal to A plus B. Is equal to what? A plus B. Is it understood? So this is the molecularity. If suppose 5 reactants are there, then number of molecularity will be how many? 6. Because individual molecularity plus overall molecularity. 5 will be individual molecularity plus overall molecularity will also be there. Okay. So now molecularity definition, is it understood? Any doubt about this? No doubt. Okay, so one thing, some salient features. Okay, what are the salient features of law of mass action? Okay, what is that? First one, it is a theoretical based concept only. Theoretical based concept only. That means, see, we require only balanced equation. Okay, so we does not require any chemicals. We did not carried out any experiment. Only concept. Okay, so it gives what it gives. It gives molecularity. Understood? Molecularity. So, and third thing is, third silent feature, it may or may not be. This is the main problem. May or may not be true in practice. Okay. So when you directly carry out this, according to this, reaction may not change. Okay. So this is the, and it gives molecularity. Okay. And that about the molecularity, can never be, first of all, 0. Okay, I will write like this, can never be 0. Why? Because If reactants moles itself is 0, how we will carry out reaction? Okay, so can never be, what is this? Can never be 0. Okay, can never be negative. Can we take -3 moles in a reaction? No, that's why can never be negative. And third one is can never be fraction. Okay, because we will carry out balancing in which there will be coefficients which are non-fractions. Normally we will suppose if there is a 2 by 3, then we will multiply the entire equation with 3, so that should not be any fractional coefficient. Okay, so these are the salient features of law of mass action. Is it understood? It is a theoretical concept, theoretical based concept only. It gives molecularity. It may or may not be true in practice, and it can never be, molecularity can never be 0, can never be negative, can never be fraction. Okay, so there are some contradictions on this. Somebody says we can balance like that, so don't worry. But as per the NCERT, as per the board pattern, as per the NTA pattern, it cannot be fraction. Is it understood? Shall we go for the next concept? What is the next concept? Good, still you remember rate law. What is the next concept we are going to start? Rate law. Okay. So there was some problem with the law of mass action. When there is a problem only, then only there will be solution. Okay. So what is the problem with the law of mass action? It may or may not be true. Okay. So it is not reliable. It will be true, but compulsory it is not there. Okay. So like when you buy a Chinese mobile, what you will say? It will run up to now, there is no problem, but there is no guarantee. Okay, like that only law of mass action situation. It will be okay, but there is no guarantee that it is always correct. So for that, there should be some hard work to give you guarantee. Okay, what is that hard work? It is rate law. Understood? Now rate law, suppose according to this rate law, okay, let us take A moles of A plus B moles of B gives what I will write? Product. Why I will write? Because products are not going to affect on rate of reaction. Okay, so rate of reaction directly proportional to A to the power of X. Okay, directly proportional to B to the power of Y. Understood? Now, what I have done in the previous similar format, only thing small change. What is that change? I think now you are able to understand. A to the power of X and B to the power of Y. Okay, so R is equal to K into A to the power of X and B to the power of Y. Understood? So this is the law of rate law. Now what is this X and Y? These X and Y are determined not from the balanced equation. They are determined experimentally. For this, experiment is compulsory. Okay. So what is rate law? Rate law is the rate of reaction. Rate law is the rate of says that rate of reaction is directly proportional to concentration of each reactant. Up to here, common definition. After that only the definition changes. Okay, so rate of reaction is directly proportional to rate concentration of each reactant, with each concentration term raised to the exponent, which is experimentally calculated, there it was numerical coefficient in balanced equation, but now what it is, which is experimentally determined. Okay, so this is the mathematical equation and definition. I think understood. You can do it or not, you can write it on your own. Can you write it? What is the statement? Rate of reaction is directly proportional to concentration of each reactant, with each concentration term raised to the exponent which is experimentally determined. Okay, is it understood? Now here this is an experimental concept. Okay, so x and y, how we are not required, from here we will only come to know what are the reactant. What for balanced equation used here? Only identifying the reactant, not for their coefficient. Their reactant also identified as well as coefficient also used in the law of mass action. Okay. Now here I will explain. This is the mathematical form. Okay. So up to now only one new thing is introduced. What is that? X and Y. Okay. So I will write it clearly now. R is equal to rate law of a equation. R is equal to K into A to the power of X and B to the power of Y. Okay. This already we know. This already we know. Only this and this. X is equal to, there it was called molecularity. Now it is called order of reaction. What it is called as? Order of reaction. But here what is it? With respect to A, capital A. Okay. Same way, what is Y? Y is order of reaction. Order of reaction with respect to B. Okay. What is Y? Order of reaction with respect to B. Order of reaction with respect to B. Next, X plus Y is overall order of reaction. Okay. Overall order of reaction. Is it understood, students? So this is about the rate law. Difference between rate law and law of mass action, which is more reliable? This is more reliable. Why? Because it got experimentally proof. Okay. So on that there will be guarantee. It is always correct because we have done and checked, cross-checked. Okay. So after cross-checking only the product will be released. What is that product? Rate law product. Okay. So there it is molecularity. Here it is order of reaction. Okay. Now we are going to study about the salient features. Okay, salient features of rate law. First one is, so it is experimental concept. What it is? It is experimental concept. That was theoretical concept. And second thing, it gives order of reaction. That gave my clarity. Okay, order of reaction. Okay, and what is the C? It is always true. It is always true because it got proof. Okay, so if it got proof, that means it is true. Okay, and order of reaction. Okay, order of reaction can be, order of reaction can be, okay, can be negative, can be zero, can be fraction. Okay, these are all not permitted in the molecularity because it is a balanced chemical equation. Now how it can be negative, how it can be zero, how it can be fraction? Any idea? Okay, I will tell you, don't worry. So negative means, generally, I told you a word, generally rate of reaction is directly proportional. Suppose if it is inversely proportional, then it will be negative. Okay, what it will be? It will be negative. Okay, so R is inversely proportional to, suppose, a to the power of 2. Okay, so then what we will write? R is equal to K into a to the power of minus 2. Okay, so here it is minus 2 or not. So negative, that means order of reaction can be negative. Okay, so order of reaction can be negative. Now sometimes what happens? There are certain reactants whose concentration is not at all going to affect the rate of reaction. Okay, so what we will write? R is equal to K, because changing concentration is not changing the rate of reaction. So R is equal to K into A to the power of 0. So that time order of reaction can be 0. Okay. When can be negative? When rate of reaction is inversely proportional to concentration. That time it can be negative. When rate of reaction independent of concentration, that time it will be 0. When rate of reaction, suppose if I am increasing the concentration 4 times, okay, but rate of reaction is increasing only 2 times, we can say directly proportional. But what we have to write, 4 to the power of 1 by 2 we should write or not. So that time it will be fraction. Okay, directly proportional only, but not exactly directly proportional. Okay, now we are going to study most important topic, rate, after the rate law. In the rate law only and in the law of mass action only, this topic is involved. Okay, what is that topic? Rate constant. Rate constant K. Okay, it is also called as what? Specific rate of reaction. Okay, rate constant or specific rate of reaction. Okay, now definition part already we have studied. What is the rate constant? It is the rate of reaction. Okay, it is the rate of reaction. Rate of reaction when concentration of all reactants taken as unity. That means all reactants concentration must be how much? 1. Okay. So that is the rate constant. Definition part, that is not a problem. It never came and I don't think it will come. But for understanding the future concepts, this was the base. That's why I have to explain. Okay. So rate constant K or specific rate of reaction. Normally constant should not have any units. Okay. But it have units and so many units. The person who is not at all supposed to have unit is having plenty of units. That is the magic of the rate constant. Okay. So how you will come to know? Let us take R is equal to K into A to the power of X and B to the power of Y. Why I am taking rate law here? Because it is most reliable. Understood? Let time take. It takes time. It takes cost. It is expensive. Okay. So, but still it is reliable. Okay. So R is equal to K into A to the power of X and B to the power of Y. Now my intention is to find out the units of K. So if my intention is this, my other intention must be clear or not. So K is equal to R divided by A to the power of X and B to the power of Y. Okay. So what are I wanted to know the units of K. Then what I will do, I will substitute the units of other things. Rate of reaction units, already I told you in my first lecture, mole, liter inverse, second inverse. Concentration by time. Concentration is mole, liter inverse, and time is second inverse. Okay. Concentration by time. Okay. Divided by concentration, here it is mole liter inverse to the power of X. Okay. Mole liter inverse to the power of Y. Is it understood? So in this situation, every human being will feel that I should do something to the mole liter inverse. It is coming every now and then. It should come only in one place. For that, what you will do? Good. Okay. So here what I will take, x plus y is equal to n. Okay. Now what is this n? Overall order of reaction. What is this? Overall order of reaction. Okay. So I am going to simplify it for simplicity. Okay. So units of K, here it is mole, liter inverse and second inverse divided by mole liter inverse to the power of x plus y. What I have taken in place of x plus y, it has n. Okay, what is n here? Order of reaction. So this can be further written as mole liter inverse to the power of, this is 1 minus n second inverse. Okay, so units of K are mole liter inverse to the power of 1 minus n and second inverse. This is most important. That's why I have kept it in box, so that valuable things must be kept it in box or not. Second inverse. Okay. Up to here is it clear? Where here, what is in here? Rest all are known. What is in here? Order of reaction. Okay. Order of reaction. But problem is that sometimes we may have gaseous reactant. So that time we may not use the molarity. That time what we will use? Partial pressure. Do you remember or not? Okay. So that time in place of the concentration, units will be ATM. Okay. Mole per liter will become as ATM. Okay. ATM to the power of 1 minus n, and it is not necessary that second inverse, it can be time inverse, it can be anything minute inverse. Okay, so concentration to the power of 1 minus n, time inverse, units of K are pressure to the power of 1 minus n and second inverse. Okay, so these are the units of K. Definition of K understood? Units of K is it understood? Now coming to the very important point. What is that important point? Is K depends. K depends only on temperature. K depends only on temperature. Okay. So these are the specific rate constant and its temperature at constant are for same reaction. For same reaction. Okay, so if reactants are same and reaction is same, then K changes not by the concentration. Okay, don't think that R is equal to K into A to the power of N and B to the power of, sorry, X and E to the power of Y. If I change this, this will change. No, this change will change this. This change will change this, but it will not change K. Okay, so any change in concentration, any change in pressure is not going to affect this our K. Okay, pressure will change this rate of reaction. Concentration will change the rate of reaction, but not K value. So how to change K? K changes only when temperature changes. Okay, so how temperature changes, that is explained by the temperature coefficient. Okay, what is the temperature coefficient? Okay, temperature coefficient is ratio of two rate constants. Ratio of what? Two rate constant. But if one is at temperature T, another should be T plus 10. What should be the another? T plus 10. Suppose one is at 300, then another should be the 310 Kelvin. If one is at 50 degrees Celsius, another should be 50 plus 10, 60 degrees Celsius. So that ratio of rate constant differed by a temperature of 10 degrees Celsius is called as temperature coefficient, and very important objective, it lies between 2 to 3. It lies between 2 to 3. What does it mean, 2 2 to 3 means rate of reaction. If it is 2 times, then rate of reaction also will become 2 times. If it is 3 times, then it will become 3 times. Okay. So according to this definition and according to this statement, normally rate of reaction becomes how many times? 2 to 3 times on increasing the temperature by every 10 degrees Celsius. Suppose temperature coefficient is 2. Okay, so temperature coefficient is 2. So at 200 to 210, if I change, then rate of reaction will increase. How many times it will increase? 2 times. Okay, if the temperature coefficient is 3, so this increase will improve the rate of reaction by 3 times. So that is the power of the temperature. It can increase by 2 times, 3 times. Okay, is it understood? Any doubt about this? Okay, so we have studied what we have studied. We have studied basically concentration, effect of concentration on the rate of reaction. Okay, so what is the main topic which we have is molecularity, and second thing is order. Okay, molecularity, from where we came to know law of mass action gives molecularity, which will give this weight law will give this. Okay, and it is may or may not be correct, may or may not be. Okay, may or may not be true. Is it understood, students? Here always true, always true. Okay, and what it is, molecularity can never be, zero, can never be negative, can never be fraction. Okay, so can be zero, can be negative, can be fraction. Okay, this is theoretical concept. What it is? Theoretical concept. What it is? Experimental concept. Okay, so likewise these are the simple revision of the molecularity and order of reaction. Okay, so based upon this also the question may come. That's why I have given a short revision of this one. Understood? So go through it once again and maintain proper notes so that the future questions, on the basis of 2 lectures, we are going to do some question series. Okay, so for that question series you should be able to understand both the lectures. So before that question series, question lecture, I want that both lectures should be perfect. Then only you will be able to answer and understand the questions. Okay, bye bye, see you.